A cosmic object 100 times bigger than anything we've ever tracked just entered our solar system, and it looks like it's hunting a smaller, equally strange visitor that arrived just weeks before. On September 12, 2025, astronomers witnessed an impossibility. Two massive, anomalous bodies arriving from opposite ends of the galaxy, set to rendezvous near the Sun. The odds are non-existent, and the evidence points not to a comet, but to a fortress. Let's explore this together. Swan's dramatic arrival. What does it look like when the impossible streaks across the sky? On September 12, 2025, we found out. The SWAN instrument, a solar wind anisotropy sensor aboard the SOHO spacecraft, flagged a new object blazing a path through the inner solar system. The first data sets, analyzed by teams led by SOHO project scientist Bernhard Fleck, were staggering. The object possessed a tail stretching nearly 2.5 degrees across the sky, about 5 times the width of a full moon. To put that in perspective, a tail of that magnitude suggests a hydrogen outgassing rate hundreds of times greater than a typical long-period comet. Its initial brightness was clocked at magnitude 7.4, luminous enough to be seen with backyard telescopes from a distance of over 150 million kilometers. This wasn't some faint smudge. This was a spectacle. News ignited across astronomy networks, and just 2 days later an amateur observer captured a jaw-dropping image showing a streak so immense it barely fit the camera's frame. It was too big, too bright, and its trajectory was already looking far too precise. The raw energy output required to generate such a visible display at that distance was the first red flag that this was something entirely new. Official recognition and growing mystery. How do you classify something that breaks all the rules? By September 13th, the Minor Planet Center, where figures like the late, great Gareth V. Williams once vetted such discoveries, made it official. The object was designated C2025R2 or SWAN, acknowledging the instrument that found it. That official stamp kicked off a global frenzy. Its initial orbital eccentricity was calculated at over 0.999. Confirming it as a long-period visitor on a path that would take millennia to repeat. The sheer size and luminosity created a wave of disbelief. Veteran astronomers had to reach back to the legendary comet Hale-Bopp of 1997, a comet with a nucleus estimated at 60 kilometers in diameter, to find a worthy comparison. SWAN, however, was already outshining Hale-Bopp at a similar distance from the Sun. It was slicing through the constellation Virgo, growing brighter as it approached its perihelion of roughly 1.0 AU, the same distance as Earth is from the Sun. The question shifted from what it was, to why it had arrived right now with such perfect timing. The numbers didn't just suggest a large object, they hinted at an impossibly active one. The cosmic coincidence. Some things are so unlikely they stop looking like a coincidence. See 2025. R2 SWAN is not the only strange visitor this October. Days before, another object, 3I Atlas, was already inbound from a completely different part of the sky. Imagine a celestial map. SWAN's path traces back from Aquarius, while Atlas entered from the direction of Sagittarius. Yet both are set to reach their closest pass by the Sun within the same 10-day window. For Atlas, that's October 17th at a distance of 1.36 AU. For SWAN, it's just 3 days later around October 20th, at a much closer 1.0 AU. Their perihelion points are separated by only about 50 million kilometers, closer than Mars ever gets to Earth. The geometry is what's truly stunning. Both are on steeply inclined orbits, with SWAN's path tilted more than 60 degrees and Atlas nearly 90 degrees to the ecliptic plane. As orbital dynamicist Paul Wiegert would tell you, the statistical probability of this kind of synchronized arrival from such different trajectories is infinitesimally small. It's a corridor in space-time that seems to have been deliberately targeted. This is not random chance, it is a rendezvous. Atlas breaks the rules. So, what do you do when an object's very existence, just flat out violates physics? 3I/Atlas, discovered by the University of Hawaii's Asteroid Terrestrial Impact Last Alert System Survey, which was headed by Larry Deneau, first got attention for its unusual composition. Early spectrographs showed a body dominated by nickel with almost no iron at all. This directly contradicts our knowledge of asteroids, which, nearly always feature iron-nickel alloys in really predictable ratios. But the anomalies didn't stop there. Instead of water vapor, Atlas's coma was pumping out carbon dioxide, with its 4.3 micron spectral line dominating every single reading. But the real smoking gun was its movement. Observers logged 3 distinct, non-gravitational accelerations, on July 29, August 14, and August 30. These weren't smooth pushes, they were sharp bursts, delivering a delta V of several meters per second each time. The behavior was so precise it was actually dubbed thrust mix modulation, which honestly implies a controlled engine burn that was adjusting its composition output. The data held up across multiple observatories, painting a pretty clear picture. This thing was under its own power and on a mission. The physics, well, simply left no other room for interpretation. Swan, the fortress. If Atlas is a nimble drone, then Swan is basically a battleship. The scale of C/2025 R2 is honestly hard to comprehend, but it's the data that paints a really radical picture, one that has driven speculators like Harvard's Avi Loeb to consider similar theories for other objects. It all began with reflectance data. Swan's core has an albedo, or reflectivity, way higher than a typical dark comet nucleus, actually matching the signature of polished metal. Some analysts argue it fits a nickel-cobalt blend, which is an alloy used for its immense strength. Then came reports of this silvery halo around the nucleus, an anomaly some folks interpret as a plasma envelope, or maybe even an electromagnetic shield. This is where it earned the nickname, the Fortress. Unlike Atlas, Swan appears steady and, well, invulnerable, refusing to fragment as it gets closer to the sun. Even its tail shows evidence of micro-thrusts, tiny rhythmic pulses at a consistent frequency that just defy natural outgassing. Add in its 22,554-year orbit, and you have an object that appears to be ancient, armored, and, yeah, on a deliberate powered course. It isn't just passing through, it's arriving. Mission theories. When a 1 in a trillion coincidence happens, you really have to consider that it wasn't a coincidence at all. The timing, the geometry, and all this anomalous behavior have fueled a bunch of mission theories. One is a scheduled refueling run, which actually fits with concepts of advanced astroengineering proposed by physicists like Freeman Dyson. A more unsettling theory is an intervention, a rendezvous to neutralize a malfunctioning unit. The estimated power levels, Atlas at 10 gigawatts and Swan at a staggering 10,000 gigawatts, suggest energy reserves needed for active maneuvering, not just passive drifting. There's also the audit chain scenario that 1I/Oumuamua in 2017 and 2I/Borisov in 2019, both on hyperbolic trajectories, were scouts. Atlas was a more advanced follow-up, and now Swan is the main event. In every single case, the sun is the rendezvous point, the most powerful energy source in the entire system. The evidence honestly forces us to ask, if this is a mission, what is the objective? These aren't just rocks, they're actors on a cosmic stage. Ancient connections. An orbit of 22,554 years is, well, a link to a different chapter of human history. The last time Swan would have passed was around 20,000 BCE, right at the peak of the last glacial maximum. Now, this is where the story connects to Göbekli Tepe, a site in Turkey built around 9500 BCE. Researcher Martin Sweatman has proposed a pretty controversial theory that its pillars are actually an astronomical observatory, recording a cataclysmic comet impact that triggered the Younger Dryas climate shift. He argues that Pillar 43 specifically tracks a long-period celestial object. But mainstream archaeologists, including the site's original lead excavator Klaus Schmidt, strongly disputed this, maintaining the carvings are symbolic. Still, the timing is, hard to ignore. If Swan is on a recurring path, its last visit coincided with a transformative period for humanity. Whether that is a coincidence or a clue remains a fiercely debated question. It adds a layer of mythic resonance to an unbelievable event, suggesting we may have seen this visitor before. The blackout window. Just when things are about to get interesting, the curtains are being drawn. From October 8th to 18th, every major ground-based observatory from the Very Large Telescope in Chile to the Keck Observatory in Hawaii is effectively blind. This solar conjunction is predictable. What isn't normal is the alleged response. According to inside sources, memos from U.S. Space Command and the ESA have directed teams to suspend all imaging. The official rationale is to protect sensitive optics from the sun's glare. But that doesn't explain why radar facilities like Arecibo's successor, which are immune to solar glare, would also be ordered to stand down. This specific detail makes the official story fall apart. Proposals for alternative observation methods have reportedly been denied, and data requests have been delayed. Several telescope allocation reviewers describe explicit orders to avoid public statements. The result is a forced information vacuum at the most critical moment. Underground resistance. When the official channels go dark, the people build their own. The blackout order may have silenced major observatories, but it ignited a firestorm in the amateur and independent astronomy communities. Veteran tracker Bill Gray put out a call to arms across public forums. Keep your scopes on the sky, log everything, and share the raw data on open-source servers. A distributed web of astronomers with powerful 14 and 20-inch telescopes answered. Collectives like the Ibero Tracker Group in Europe began pooling their photometric and astrometric data feeds. Leaks suggest plans to use radio telescopes to pierce the solar glare. This grassroots effort has become the only real-time source for what might happen during the blackout. It's a powerful narrative of decentralized science, a global network ensuring no data disappears. When Swan and Atlas re-emerge, the first images confirming their post-perihelion behavior might come from a garage, not a government lab. This has become a testament to citizen science. Power estimates and implications. Let's talk about the energy required to make these objects move. Atlas's accelerations required a power source of around 10 gigawatts, the output of 10 large nuclear power plants, but that is dwarfed by Swan. Based on its luminosity, its suspected micro-thrusts, and the energy needed for a plasma shield, the Fortress could be wielding something close to 10,000 gigawatts. That is more raw output than the entire power grid of planet Earth combined. On the Kardashev scale, a civilization capable of controlling energy on this level is approaching Type 1 status. These are not trivial anomalies. These figures are the hardest evidence to dismiss as natural phenomena. They move the conversation from astronomy into astroengineering and contact theory. The sheer physics involves screams that we are dealing with a technology far beyond our own, powered by a source we can't yet comprehend. This is the bottom line that makes the engineered object hypothesis so compellingly logical. The facts are as clear as they are unnerving. Two anomalous objects defying all statistical odds have entered our solar system on a synchronized path. One appears to be a powered drone, the other an armored fortress. They are scheduled for a close encounter during a 10-day window, where they will be conveniently hidden from our best telescopes by the sun, accompanied by an official, top-down order for radio silence. This has forced the search for answers into the hands of a global network of citizen scientists. Are we witnessing a cosmic accident, a pre-planned mission, or something else entirely? Whatever the truth is, we are about to find out. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Sci and Why. NASA's James Webb Space Telescope has achieved a groundbreaking feat by capturing the first real image of the enigmatic interstellar object, 3Y Atlas. This remarkable milestone opens a new chapter in our understanding of cosmic wanderers and the mysteries they hold. The data reveals unprecedented details that challenge previous notions about interstellar visitors. Join us as we unravel the story behind the flicker in the telescope's data leading to this profound discovery, the object's incredible speed from the void, and the secrets it may unlock about our universe. The flicker in the data. In late 2025, astronomers noticed a faint flicker within vast datasets collected by advanced telescopes across multiple observatories worldwide. Initially dismissed as background noise or instrumental error, this subtle signal sparked curiosity among researchers at NASA when artificial intelligence algorithms began flagging anomalous patterns. Analysts utilized cutting-edge machine learning algorithms to isolate these anomalous data points corresponding to an object moving at extraordinary speed through our galaxy. Subsequent observations confirmed the flicker as 3Y Atlas, a massive interstellar visitor entering our solar system from the depths of space. This serendipitous detection was a testament to the increasingly sophisticated analytical methods enabling the discovery of elusive cosmic travelers from the vast interstellar void. The discovery process highlighted how modern astronomy relies on both advanced technology and human intuition to identify phenomena that would have been completely invisible to previous generations of scientists. The flicker represented humanity's first glimpse of what would become the most significant interstellar discovery since Oumuamua, offering unprecedented insights into phenomena previously beyond our reach and understanding. 152,000 miles per hour from the void. 3I Atlas barrels through space at a staggering velocity of approximately 152,000 miles per hour, or about 68 kilometers per second, defying all known celestial norms and expectations for objects in our cosmic neighborhood. This extraordinary speed has been confirmed through precise orbital tracking conducted by teams at NASA's Jet Propulsion Laboratory, utilizing multiple ground-based and space-based observation platforms. The velocity calculations show this speed dwarfs any traditional simulation of interstellar objects passing through our solar system, suggesting origins from an incredibly distant star system. Such immense velocity indicates the object has traversed the vast interstellar void for potentially millions of years, subjected to cosmic radiation bombardment and gravitational perturbations from countless stellar encounters. Its trajectory through the ecliptic plane positions it for brief but critical visibility windows, prompting astronomers worldwide to mobilize for intensive observation campaigns using every available telescope and sensor array. Understanding this rapid journey through space enhances our fundamental grasp of galactic dynamics and the frequency of alien visitors crossing our cosmic neighborhood, while raising profound questions about the forces that could accelerate such massive objects to these incredible speeds. 3 visitors, 7 years. Since the epical discovery of Oumuamua in 2017, followed by the comet-like 2I Borisov in 2019, humanity has witnessed 3 confirmed interstellar intruders within a span of just 8 years. This unprecedented sequence has fundamentally transformed our perception of the solar system's place within the broader galactic environment and the frequency of cosmic visitors. Each visitor displays unique physical and dynamic attributes, painting an increasingly complex picture of materials ejected from diverse planetary systems across the galaxy. The arrival of 3I Atlas, significantly larger and faster than its predecessors, magnifies the urgency in understanding the true diversity and origin of such objects in our cosmic neighborhood. As observational technology advances and detection methods become more sophisticated, the frequency of such encounters may reveal long-hidden cosmic realities about interstellar traffic patterns. The pattern suggests that interstellar visitors may be far more common than previously imagined, fundamentally challenging our understanding of solar system dynamics and the movement of matter between star systems. These discoveries collectively indicate that our solar system exists within a much more active and dynamic galactic environment than scientists previously recognized, with implications for planetary formation, asteroid populations, and the potential for life-bearing materials to travel between worlds. James Webb's metallic discovery. So James Webb's metallic discovery, well, the James Webb Space Telescope's recent high-resolution imaging of 3I/Atlas, has delivered completely unexpected revelations about its surface properties and composition, and honestly, these findings have just stunned the scientific community. Comprehensive spectral analysis, which was conducted by Dr. Liam Cheng and his international research team, detected a predominantly metallic composition. This fundamentally challenges those long-held assumptions that interstellar objects are mostly icy or rocky bodies. Now, this distinctive metallic signature, it suggests either advanced natural processing through some truly extreme cosmic conditions, or, potentially, artificial construction by unknown technological means. Reflected light patterns captured by Webb's advanced infrared instruments indicate an unusually smooth, potentially engineered surface, instead of the rough, pitted texture that's typical of natural asteroids or comets. The metallic composition even appears to include elements not commonly found in typical solar system objects, like rare earth metals and isotopes that suggest formation under, well, exotic stellar conditions. These groundbreaking findings open the door to revolutionary hypotheses regarding non-natural origins, and they're really compelling scientists worldwide to expand their investigative methodologies and fundamentally reconsider their definitions of cosmic phenomena. The discovery has prompted emergency funding for additional observation time, and it's sparked some intense international collaboration to analyze every detail of this unprecedented visitor before it disappears forever into the depths of space. The machine that steers itself. This is honestly one of the most astonishing and scientifically challenging aspects of 3I/Atlas. It's the object's apparent ability to modify its trajectory mid-course, which strongly implies the presence of an intrinsic navigation or guidance system. Groundbreaking research led by aerospace engineer Dr. Sofia Martinez has documented subtle but measurable variations in velocity and orientation that just remain completely inconsistent with gravitational influences alone. These adaptive steering capabilities suggest highly sophisticated onboard systems, either responding intelligently to external stimuli or fulfilling some form of pre-programmed interstellar mission. This phenomenon, well, it raises some profound and honestly unsettling questions about whether such objects represent autonomous probes, rather than just mere geological debris drifting through space. The trajectory adjustments seem to occur at specific intervals and follow patterns that suggest deliberate course corrections, probably designed to optimize the object's path through our solar system. Such capabilities would require technology far beyond anything currently possessed by human civilization, involving either advanced artificial intelligence or direct control by some form of intelligence. The implications here challenge existing space exploration frameworks, and they invite some pretty serious speculation about extraterrestrial engineering and the possibility that 3I/Atlas represents humanity's first encounter with genuine alien technology actively operating within our solar system. Information blackout. Despite intense scientific scrutiny from observatories worldwide, much crucial information about 3I/Atlas still remains, well, mysteriously enigmatic due to unprecedented government-imposed data restrictions and communication blackouts. Classified satellite data and systematic communications jamming really hint at a broader, coordinated information suppression campaign designed to deliberately suppress sensitive knowledge regarding the object's true nature and potential origins. Whistleblowers, including former intelligence officer Dr. Eleanor Hayes, suggest that agencies across multiple governments participate in coordinated secrecy operations that span international boundaries. This systematic information blackout has fueled widespread conspiracy theories and public frustration, while at the same time underscoring the immense challenges legitimate scientists face in accessing comprehensive datasets needed for proper analysis. The restrictions appear to target specific wavelengths of electromagnetic observation and particular types of gravitational measurements, which suggests authorities know exactly what they want to conceal from public knowledge. Transparency advocates and scientific organizations worldwide argue vigorously for immediate declassification to advance scientific understanding and, properly prepare humanity for potential first contact scenarios. The secrecy has created an unprecedented divide between official government statements and the growing body of leaked evidence, suggesting 3I/Atlas represents something far more significant than a simple interstellar asteroid. Adaptive shielding technology. So, recent theoretical models developed by leading physicists propose that 3I/Atlas employs this, highly advanced adaptive shielding technology. It's apparently capable of rendering it nearly invisible to conventional detection methods, and that's across multiple electromagnetic spectra. The Max Planck Institute, they've elaborated on these sophisticated hypotheses involving electromagnetic cloaking fields and dynamic surface morphing, which could help explain the object's, mysteriously elusive signatures. Such revolutionary shielding technology would, at least in theory, allow the object to systematically evade host planetary defense systems and observational arrays, basically making completely discrete movement through solar systems possible. The proposed technology involves real-time manipulation of electromagnetic properties, possibly through programmable metamaterials that can alter their reflective and absorptive characteristics instantaneously. Investigations into these extraordinary properties may, honestly, revolutionize human understanding of stealth technology, with some pretty profound implications for both planetary defense systems and future space exploration capabilities. The adaptive shielding seems to actually respond to different types of observation attempts, becoming more transparent to certain wavelengths while staying opaque to others, in patterns that, suggest intelligent control. If confirmed, this technology would represent a quantum leap in material science and electromagnetic manipulation, far beyond anything achievable with current human knowledge, and could potentially provide blueprints for revolutionary advances in spacecraft design and planetary protection systems. The Ancient Probe Network. So, emerging evidence increasingly suggests that 3I/Atlas might represent a crucial component of a vast ancient probe network, potentially constituting a galactic surveillance system initiated by an advanced civilization that predates human existence by millions of years. Leading astrobiologist Dr. Maya Singh describes how such interconnected probes could, in theory, monitor planetary systems across thousands of light-years, relaying comprehensive information through quantum entanglement communication systems or, even faster-than-light transmission methods. These sophisticated networks might encode prime number sequences within their thermal signatures, functioning as distinguishing identification markers or complex mathematical messages designed for detection by emerging technological civilizations. The probe network theory, honestly, suggests a level of galactic organization and long-term planning that completely transcends human technological capabilities and temporal perspectives. Each probe would operate semi-autonomously while maintaining connection to a larger intelligence network, gathering data on planetary development, biological evolution, and technological advancement across, countless worlds. Such a discovery would fundamentally redefine humanity's place in the cosmos, indicating we exist within a much larger, interconnected interstellar intelligence system that has been operating for eons. The implications extend really beyond mere scientific curiosity, suggesting that human development may have been observed and possibly influenced by these ancient sentinels, heralding a new era in astronomical, philosophical, and existential understanding of our role in the universe. Prime numbers in heat signatures. Scientists analyzing the thermal emissions from 3I/Atlas have detected increasingly intriguing patterns featuring prime number sequences, which, many researchers interpret as deliberate mathematical signals rather than just random electromagnetic noise. A renowned mathematician emphasizes that these precise numerological features could represent a sophisticated, intelligent encoding method, strongly indicating deliberate communicative intent from the object. These remarkable findings add substantial credence to the hypothesis that 3I/Atlas represents an artificial probe, and they've sparked unprecedented new interdisciplinary studies combining advanced astrophysics with information theory and cryptographic analysis. The presence of prime number sequences in electromagnetic emissions is widely considered among scientists as, honestly, potentially universal evidence of technological civilization, effectively bridging the gap between purely cosmic phenomena and potential extraterrestrial intelligence communications. The patterns appear in multiple frequency ranges and follow mathematical progressions that would be, virtually impossible to produce through natural processes alone. The sequences begin with simple primes like 2, 3, 5, and 7, then progress to increasingly complex mathematical relationships that suggest a deliberately constructed communication protocol. International teams of mathematicians and physicists are working around the clock to decode additional layers of meaning embedded within these thermal signatures, while astronomers continue monitoring for any changes in the transmission patterns that might indicate active communication attempts or responses to human observation efforts. We were never the observers. The revolutionary notion that humanity has never been the sole observers of the cosmos is, honestly, gaining unprecedented traction through intensive study of 3I/Atlas and its profound implications for our understanding of galactic civilization. Ongoing research strongly suggests that Earth has been an integral part of a carefully monitored network within a complex universe where multiple advanced civilizations may observe and interact discreetly across vast interstellar distances. A philosopher promotes the groundbreaking idea that 3I/Atlas may represent a sophisticated sentinel, serving as a stark reminder that our species has been under systematic scrutiny by significantly more advanced intelligences throughout our evolutionary development. This paradigm-shifting revelation fundamentally challenges deeply ingrained anthropocentric worldviews and invites, profound reflection on the true nature of consciousness, intelligence, and existence within a potentially vast, collaborative galactic community. The evidence suggests that what we interpreted as humanity's journey of discovery and exploration has actually been occurring under the watchful eyes of ancient observers who have been cataloging our progress for millennia. This realization transforms our entire perspective on human achievement, technological development, and our future role in what appears to be a much more interconnected and sophisticated cosmic civilization than we ever dared imagine, fundamentally altering our approach to space exploration, scientific research, and our search for extraterrestrial intelligence. James Webb's capture of 3I/Atlas's first real image marks a historic milestone in humanity's encounter with the cosmos and our understanding of our place within it. The implications resonate across science, philosophy, and society, hinting that we may be standing on the threshold of profound discovery and possible first contact with extraterrestrial intelligence. What are your thoughts on these revelations? Share your perspectives in the comments. Subscribe to CI and Y for more cosmic insights, and continue looking upward to the stars where ancient mysteries await our discovery. On September 26, 2022, NASA achieved something truly unprecedented. They deliberately crashed a spacecraft into an asteroid at 6.6 kilometers per second and, get this, completely changed its orbit. The DART mission wasn't just about proving we could hit a space rock. No, it was humanity's first successful test of planetary defense technology. But what happened after the collision honestly shocked scientists and revealed truths about asteroids that nobody really expected. The aftermath of this cosmic collision is rewriting everything we thought we knew about protecting Earth from space threats. The journey to impact. NASA's Double Asteroid Redirection Test, or DART, began its historic journey on November 24, 2021, launching from Cape Canaveral Space Launch Complex 40 atop a SpaceX Falcon 9 rocket. The refrigerator-sized spacecraft traveled for nearly 10 months across 11 million kilometers of space to reach its target, a small asteroid moonlet called Dimorphos. The mission team, led by project scientist Dr. Nancy Chabot at the Johns Hopkins Applied Physics Laboratory, had meticulously planned every detail of this unprecedented experiment. Unlike previous space missions that aimed to study celestial objects, DART was designed with one purpose: to slam into Dimorphos and change its orbital path around the larger asteroid Didymos. The spacecraft carried advanced navigation systems that would allow it to autonomously guide itself to impact during the final 4 hours of flight, since the 11-minute communication delay with Earth made real-time control totally impossible. As DART approached its target, onboard cameras captured dramatic images of the asteroid growing larger and larger, marking humanity's first intentional collision with another world for planetary defense purposes. The perfect target. Dimorphos proved to be the ideal testing ground for this groundbreaking experiment, measuring approximately 160 meters in diameter and orbiting its larger companion Didymos every 11.9 hours. The binary asteroid system, located about 11 million kilometers from Earth at the time of impact, posed no threat to our planet, making it a safe target for this high-stakes test. Didymos, the larger asteroid measuring 780 meters across, served as the gravitational anchor for its smaller moonlet. Scientists chose this system because any change in Dimorphos's orbit could be precisely measured from Earth using ground-based telescopes and radar systems. The asteroid pair was discovered in 1996 and had been extensively studied, providing researchers with detailed baseline measurements of their orbital characteristics. The proximity of the two asteroids meant that even a small change in Dimorphos's velocity would produce a measurable shift in its orbital period around Didymos. This binary system represented the perfect natural laboratory for testing kinetic impactor technology, close enough to Earth for accurate observation, large enough to produce detectable changes, yet far enough away to ensure complete safety for our planet throughout the experiment. The moment of impact. At exactly 23:14 UTC on September 26, 2022, DART slammed into Dimorphos at a closing speed of 6.14 kilometers per second, releasing kinetic energy equivalent to approximately 2.5 tons of TNT. The collision occurred with pinpoint accuracy, striking the asteroid's surface and instantly vaporizing the 610-kilogram spacecraft along with a portion of the asteroid's rocky material. Ground-based telescopes around the world captured the dramatic moment as a brilliant flash of light erupted from the impact site, followed by an expanding cloud of debris that grew brighter over several hours. The Hubble Space Telescope and James Webb Space Telescope immediately began observing the aftermath, documenting the evolution of the ejecta plume as it stretched across thousands of kilometers of space. Within minutes of impact, the debris cloud had expanded beyond Dimorphos itself, creating a spectacular tail of material that resembled a comet's tail stretching behind the asteroid. Amateur astronomers joined professional observatories in tracking the collision's effects, witnessing history as humanity demonstrated its ability to alter the path of a celestial object. The impact created seismic waves that rippled across Dimorphos's surface, potentially reshaping the asteroid's internal structure in ways that scientists are still working to understand. beyond all expectations. The results of the DART impact exceeded every prediction and shattered the mission's success criteria. Instead of the minimum 73-second change in orbital period that would have declared the test successful, Dimorphos's orbit around Didymos shortened by an astounding 32 minutes. This dramatic change represented a 26-fold improvement over the mission's baseline requirements, proving that kinetic impactor technology was far more effective than scientists had dared to hope. The massive orbital change resulted not just from the direct momentum transfer of the spacecraft's impact, but from the unexpected efficiency of the momentum multiplication effect created by the ejected debris. As material blasted away from the impact site, it carried additional momentum in the opposite direction, acting like a natural rocket engine that amplified the deflection effect. Dr. Tom Statler, DART program scientist at NASA, described the results as a watershed moment for planetary defense and humanity's ability to influence our cosmic environment. The orbital change was so significant that it could be measured by small telescopes and even confirmed by radar observations from Arecibo Observatory and the Goldstone Deep Space Communications Complex. This level of deflection meant that if Dimorphos had been on a collision course with Earth, the impact would have shifted its trajectory by hundreds of thousands of kilometers. The mysterious ejecta cloud. The debris cloud created by DART's impact revealed secrets about asteroid composition that puzzled scientists worldwide. Instead of the uniform dust plume that computer models predicted, the ejecta displayed complex structures including multiple debris streams, spiral patterns, and irregular particle distributions that suggested Dimorphos had a far more complex internal structure than anticipated. Dr. Christina Thomas at Northern Arizona University, who led the observational campaign, noted that the debris cloud evolved in unexpected ways over the following weeks. Some particles were ejected at speeds exceeding 500 meters per second, while others moved much more slowly, creating distinct populations of material with different trajectories and behaviors. The cloud's asymmetric shape indicated that Dimorphos wasn't a solid, uniform rock, but likely a rubble pile, a loose collection of smaller rocks and boulders held together by weak gravitational forces. High-resolution images from ground-based telescopes revealed that the ejecta contained both fine dust particles and larger chunks of material, some potentially meters in size. The debris cloud's brightness variations suggested that different types of material were being ejected from various depths within the asteroid, providing unprecedented insights into the internal layering and composition of small solar system bodies. Hera's investigative mission. Recognizing the need to understand DART's impact in detail, the European Space Agency launched the Hera mission in October 2024 to conduct a comprehensive post-impact investigation. This follow-up mission represents an unprecedented example of international cooperation in planetary defense, with Hera scheduled to arrive at the Didymos system in late 2026 to examine the crater left by DART's collision. The spacecraft carries advanced instruments including high-resolution cameras, thermal imagers, and radar subsystems designed to map both asteroids down to centimeter-scale resolution. Hera will measure the precise size and depth of DART's impact crater, analyze the composition of exposed subsurface material, and determine how the impact altered the internal structure of both Dimorphos and its parent asteroid Didymos. The mission will also deploy two small CubeSats called Juventus and Milani to conduct complementary investigations, including the first radar sounding of an asteroid's interior and detailed gravitational field mapping. Dr. Patrick Michel, Hera's principal investigator, emphasized that understanding the physical properties revealed by DART's impact is crucial for designing future deflection missions. The data collected by Hera will validate computer models used to predict deflection effectiveness and provide the foundation for operational planetary defense systems. Unraveling asteroid mysteries. The DART impact revealed that small asteroids like Dimorphos are far more complex than scientists previously understood, fundamentally changing how we think about these cosmic building blocks. Pre-impact models assumed asteroids were relatively simple objects with predictable responses to external forces, but the dramatic success of the deflection demonstrated that rubble pile asteroids behave more like fluid structures than solid rocks. Dr. Andy Rivkin at the Johns Hopkins Applied Physics Laboratory noted that the impact's efficiency suggested Dimorphos has very low internal cohesion, allowing the impact energy to propagate throughout the entire structure and eject material from multiple locations. The asteroid's surface appears to be covered in loose regolith, fine, rocky debris accumulated over millions of years that was easily disturbed by the impact's shock waves. Spectroscopic observations of the ejecta revealed that Dimorphos contains ordinary chondrite minerals similar to the most common meteorites found on Earth, but with unusual proportions that suggest a complex formation history. The impact also provided insights into how small asteroids respond to tidal forces from their parent bodies, with evidence suggesting that Dimorphos experiences ongoing surface changes due to its proximity to Didymos. These discoveries have profound implications for understanding asteroid evolution, the formation of binary systems, and the potential resources available on near-Earth asteroids for future space missions. Complications for future defense. While DART proved that kinetic impactors can deflect asteroids, the mission also revealed complications that will influence future planetary defense strategies. The unexpectedly large orbital change, while impressive, highlighted just how difficult it is to predict exactly how different asteroids will respond to impact. Dr. Nancy Chabot emphasized that the momentum multiplication factor, the ratio of total momentum change to the spacecraft's initial momentum, varied significantly from pre-impact predictions, reaching values between 2.2 and 4.9 depending on the measurement method. This variability means that future deflection missions will require detailed advanced characterization of target asteroids to predict their response accurately. The complex ejecta pattern suggested that asteroid internal structure, surface composition, and rotation state all influence deflection efficiency in ways that current models just don't fully capture. The discovery that small asteroids behave more like loosely bound rubble piles than solid objects means that deflection strategies must account for potentially dramatic differences in material properties between different asteroid types. Mission planners now recognize that successful planetary defense will require a library of deflection techniques tailored to specific asteroid characteristics, rather than a one-size-fits-all approach. The DART results also emphasize the importance of early detection and characterization, since deflection effectiveness depends critically on understanding an asteroid's physical properties years before any potential impact threat. Global Planetary Defense Initiative. The success of the DART mission has catalyzed unprecedented international cooperation in planetary defense, transforming what was once considered science fiction into practical space policy. NASA's Planetary Defense Coordination Office, established in 2016, now works closely with the European Space Agency, Japan's JAXA, and other international partners to develop comprehensive strategies for detecting and deflecting hazardous near-Earth objects. The United Nations Office for Outer Space Affairs has established new protocols for sharing asteroid tracking data and coordinating deflection missions, recognizing that planetary defense is a global responsibility requiring multinational collaboration. Ground-based survey telescopes like the Catalina Sky Survey in Arizona and the Linear program in New Mexico continue discovering new potentially hazardous asteroids at rates exceeding 1,000 per year, building a comprehensive catalog of objects that might someday threaten Earth. Space-based detection systems, including NASA's NEOWISE mission and the planned NEO Surveyor telescope, will dramatically improve our ability to find and track smaller asteroids that ground-based systems might miss. The establishment of the International Asteroid Warning Network ensures that discovery data reaches decision-makers quickly enough to enable deflection missions if needed. These coordinated efforts represent humanity's first serious attempt to protect our planet from cosmic threats that have caused mass extinctions throughout Earth's history. The future of planetary defense. The DART mission's spectacular success has laid the foundation for humanity's first operational planetary defense system, but it also revealed how much we still need to learn about deflecting dangerous asteroids. Future missions will build on DART's legacy by testing different deflection techniques including gravity tractors, nuclear standoff detonations, and enhanced kinetic impactors designed for specific asteroid types and threat scenarios. NASA's follow-up missions are already in development, including concepts for multi-spacecraft deflection systems that could handle larger asteroids or provide backup capabilities for critical deflection attempts. The double asteroid redirection test proved that humanity possesses the technological capability to alter the course of celestial objects, marking our species' transition from passive observers of cosmic events to active participants in shaping our solar system's dynamics. Advanced computer simulations now incorporate DART's impact data to model deflection scenarios with unprecedented accuracy, enabling mission planners to design precise interventions for specific threat asteroids. The mission's success has also sparked development of rapid response deflection technologies that could be deployed on shorter timescales for newly discovered threats. Most importantly, DART demonstrated that international cooperation and scientific expertise can overcome seemingly impossible challenges, providing a template for tackling other global threats that require coordinated human action on planetary scales. So there you have it. NASA didn't just hit an asteroid, they revolutionized planetary defense and revealed that asteroids are far stranger than we imagined. Which discovery about the DART mission surprised you the most? Let me know in the comments below. If you enjoyed learning about humanity's first successful planetary defense test, make sure to like this video, share it with someone who loves real space breakthroughs, and don't forget to subscribe to Sci and Y for more incredible discoveries about our universe. Until next time, keep exploring the cosmos.